Good evening all of you. Today we are discussing about the gear manufacturing. So what are the gears? Gears is one of the important machine tool elements which is an integral or the inevitable part of the power transmission system. A gear is a round blank having a number of teeth along its periphery. Gears are used to transfer the power or the torque from prime mover such as electric motor to the application where it is required. Along with the transmission of power, gears also transfers the accurate velocity ratio between two shafts. So in this diagram the principle of the gears are explained. So there is a driver gear which is fixed with the prime mover such as electric motor through this driver shaft. It is engaged through number of teeth on its periphery with the driven gear fixed on this driven shaft, which is attached to the application where it is required. So when the electric motor given the RPM through the driver shaft to the driver gear, it transfers the power or the RPM to this driver gear through the engagement of the gears, and this rotation of the driven gear transfers the RPM to the driven shaft to the application where it is required. So what are the application of the gears? So generally gears are used in the speed gear boxes or the feed gear boxes or some kinematic units in the different machineries or the machine tools in the industries. They are also used in speed drives in textile, jute or similar kind of the industries. Gearboxes are used in the automobiles or the vehicles for the different kind of the speed achievements. Speed and or the feed drives of the several sheet metal forming industries. They are also used in the machineries in the mining or the tea processing industries. The large gears are generally used in the large or the heavy duty gearboxes in the cement industries, sugar industries, cranes, conveyors or the shipping industries. Small gears or the precision gears are also used in precision equipment such as watches and the clocks. Gears are also used in industrial robots and the toys also. So what are the types of gears? So first type of the gear is spur gears. As we have seen in this animation, the spur gear has straight teeth engaged with each other. The second type of the gears are the helical gears, in which the gear teeth are not straight but they are inclined somewhat and they are engaged and worked as shown in this animation. The third type of the gears are the bevel gears, in which the axis of rotation of the driven and driver gear are not parallel as the previous gears, but the axis of the rotation of the engaged gears are perpendicular to each other. So it is used to transfer the motion from the horizontal axis to the vertical axis where it is required. And last type of the gears are the worm and the worm mill gears. So in this animation, the working of the worm and wall is given. So this is the worm wheel having the number of teeth, and this is the worm on the worm shaft. So it will transfer the rotation as shown in this animation, that is the pitch rotation of this worm transfers the revolution or the RPM to this worm wheel. So what are the gear materials are used for gear manufacturing? Generally ferrous metals are used for the gears having the application in the high load applications. So grey cast iron are recommended for the reasonably high strength or the wear resistance. They are having ease of casting and machining with the low cost material. Forged or rolled high carbon steels or alloy steels are used either if fully hardened or surface enriched condition under the high stresses and the speed. Some non-ferrous materials gears are also used for lightweight application such as aluminum, brass. They are used for making gears having fine teeth and working at very light loads. that is equipments like toys or the against the hard steel mating gears. Aluminum alloys like aluminum, bronze and zinc alloys. Aluminum alloys are also used for manufacture of light load gears. Some non-metal gears such as polymers or the plastic in the form of thermoplastic or the thermosetting type, or the some composite materials are also used for manufacturing the gears such as graphite, wood dust or the cement powders, depending upon the application of the gears. So what the gear manufacturing process? Generally gear manufacturing process involves different steps like preforming the blank without or with the teeth, the annealing of this blank if required as in case of forged or cast steels, preparation of the gear blank to the required dimension by machining, production or manufacturing of the gear teeth or finishing by preformed teeth by machining process, full or surface hardening of the machined gear teeth if required, the finishing teeth if required by shaving or the grinding process, and the inspection of the finished gears for the dimensional or tolerance or the accuracy of the gear. So gear can be manufactured either by casting or the manufactured by rolling also. So gear blanks, even gears along with the teeth requiring substantial to little machining or finishing are produced by different kind of casting process also. The gears the manufactured by rolling also. The straight and helical teeth of disc or rod type external steel gears of small to medium diameter and the module are generated by cold rolling process either by flat dies or circular dies. Such rolling imparts high accuracy and interface surface integrity of the teeth which are formed by material flow. Unlike the cutting, gear rolling is reasonably employed for high productivity and high quality through initial machinery cost which are relatively high. Larger size gears are formed by hot rolling and then finished by machining. So gear manufacturing by rolling is explained here. The gear blank or the gear workpiece is mounted in between these flat dies. So actual view or the actual mechanism is explained in this diagram. There is upper roll and the lower roll is there, and between this upper roll and the lower roll the gear blank or the workpiece is engaged between the gap between this upper and roller dies. So the space in between this upper and lower roll dies are adjusted depending upon the depth of the cut of the teeth or the diameter of the gear blank. So upper and lower rolling dies, they are imparting pressure on this gear blank along with the rolling action which pushes or the pressurize this gear blank to form the gear teeth or the gear teeth space. The another method of the production of gear teeth is by machining on forming principle or the forming principle. So gears are either manufactured by shaping, planing or the slotting principle as well. So the teeth of straight toothed spur gear can be produced in shaping machine if required. Both the productivity and product quality are very low in the shaping process, which therefore it is used for limited application where the one or few teeth on one or two pieces of gears as and when required. Generally it is used for repair and maintenance of the gears. In principle, planing and slotting machine are also used for the manufacturing of the gears which has the same principle as the shaping machine. Planing machine is used if required at all for making the teeth of large gears, whereas slotting generally used for internal gears manufacturing. So in this diagram it shows that gear manufacturing by the ordinary shaping machine, in which the tool is reciprocating forward and backward along with this shaping tool which can cut the teeth space on this gear blank, and after cutting and giving the depth of the cut this gear blank is indexed to the next teeth space, and this can continues of the cutting of the teeth space till the completion of the all the teeth on this gear blank. The second type of the gear manufacturing is by the milling. Gear teeth can be produced by both disc and end mill type of form milling cutter, as shown in this diagram. So production of gear teeth by form mill cutting are characterized by use of high speed steel, that is HSS form milling cutters. They use the ordinary milling machines. They have the low production rate for need of indexing after the machining each tooth gap. It has the slow speed and the feed of the depth. Then the gear management milling has the low accuracy and surface finish. They have the inventory problem due to the need of set up number of cutters for each module. End mill type cutters are generally used for teeth of large gears and of the module. So in this diagram we can see there is a manufacturing gear using the disc type cutter and the end mill type of the cutter. So disc type cutter is used having the number of cutters on this disc type cutter. It can cut the tooth gap between or on the this gear blank. After cutting up the teeth gap, it can be indexed for the next gear to the gap manufacturing, and continues to cut the teeth gap till the end of the all the teeths. The second type of the gear manufacturing is the end mill type of the milling, in which the form milling cutter is used, that is the end mill type of the cutter is used of the shape required in between the two teeth, that is the tooth gap. So it is rotated as well as it is given the depth of cut during the cutting of this tooth space on this gear blank, and after cutting of the one gear teeth gap or the space, this gear blank is given the index to the next tooth gap, and it continues till the manufacturing of all the teeth on the gear blank. The next type of the gear manufacturing is by Sunderland method using a rack type of the cutter. So the principle of this generation process, where the rack type of HSS cutter, that is a high speed steel cutter having a rake and clearance angle, generally it reciprocates to accomplish the machining or the cutting action, while rolling type interaction with the gear blank like pair of rack and pinion. So this diagram explains the rack type cutting mechanism, that is Sunderland method of manufacturing the gears, in which this gear blank is fixed on the dividing head spindle, which can be indexed one after the another teeth manufacturing, and it is engaged with this rack type of the cutter having the geometry of the teeth required on the gear blank. So either this rack cut is reciprocating or the given depth of feed of the cut on this gear blank. So after having the reciprocating of this rack engaged with this gear blank, it cuts the teeth on this gear blank, and as the cut toothpaste cutting action happens, this gear blank is indexed to the next toothpaste, and it continues till the manufacturing hold the teeth on this gear blank. The another method of gear manufacturing is the gear shaping process. So gear shaping is similar to the rack type of cutting process, except that instead of using the linear type rack cutter, here we are using the circular type of the cutter having number of cutters on this cutter. So both the cutter and the blank rotate, that is this circular cutter as well as this gear blank, they are rotated just like a pair of the spur gears, in addition to the reciprocating action of this cutter. So the rack circular cutter is engaged with this gear blank, and it is indexed or that is fixed on the dividing head spindle, and as the teeth is cut down, it is indexed to the next teeth space. So this reciprocating circular cutter is reciprocates and given the depth of cut, and it is also rotating in engagement with these gears, and it continuously indexed this gear blank till the complete manufacture of the teeth on this gear blank. The same gear shaping principle is also used for the manufacturing of the internal gears. They have the similar principle as this one, but Instead of manufacturing the gears on the external periphery, it generates the gear teeth on the internal surface of the gear blank. The next process of gear manufacturing is by the gear hobbing. So where the HSS or the carbide cutter having teeth like gear milling cutter and the gear blank apparently interact like pair of the worm and the worm wheel. The hob or the cutter looks and behaves like a single or multiple start worm, having lesser number, only 3 of the tool. The work motions hobbing machines are much more rigid, strong and productive than the gear shaping machine, but the hobbing involves lesser accuracy and finish and is used only for cutting straight or the helical teeth single of external spur gears or the worm wheels. So in this diagram we can see the gear teeth manufacturing using the hobbing process. So this is the hob, somewhat inclined in shape, having the number of teeth cutters, and it is engaged with this gear blank. Here we can see that is the straight spur gears teeth are manufactured using this hob. So we can cut the helical gears, that is inclined teeth, on the gear blank using the hob with the multiple cutters, but the inclination is more than the straight teeth cutters. Also we can manufacture the worm wheel using this hobbing process, using this hob with the multiple cutters is engaged with this gear blank, and it manufactures the worm wheel also. So we will see the demonstration or the animation of these gear manufacturing processes. So we'll first see the gear generation using rack type of the linear type of the rack cutter, in which there is a rack cutter or the linear rack cutter is engaged with this gear blank, which is fixed on this arbor connected with this dividing or indexing head. This is the indexing mechanism along with this index plate. This is the table on which gear blank or the gear workpiece fixed on this dividing head reciprocates on the table along with this tailstock. So during this cutting action, the rack type cutter or linear cutter is fed vertically downward along with the depth of cut required, and it will generate the teeth cutting by reciprocating action of this gear blank on the table. After completion of one tooth, gear blank and the rack cutter are rotated to the next piece distance using indexing mechanism, and this is repeated till the end of the manufacture all the teeth. The next type of gear generation is using the pinion type of the cutter, in which this pinion, which is similar to the spur gear or the gear space required. So this is the pinion cutter and this is the gear blank or the workpiece. So gear cutter is simultaneously reciprocating vertical up and down along with rotation. It is engaged with this gear blank, which is also rotating, engaged with this rack cutter. It will cut the cutting action will generate the teeth on this gear blank along with the rotating direction. So after cutting of the completion of the one teeth, pinion cutter and the gear blank is indexed to the next tooth, and using the indexing mechanism on the rotary table, and repeat the same for remaining teeth. The next type of the gear manufacturing is by the gear hobbing, in which here we can see there is a gear blank or the workpiece attached to this arbor. It is engaged with this hob having the multiple cutters, which is fixed with the reciprocating head. So along with this hob is rotating. The multiple cutters are engaged with this gear blank. They will cut the depth of cut on this gear blank, required depth, by using this vertical up and down reciprocating motion. Along with it is rotating while it is engaged with this gear blank. So gear blank or the gear workpiece is also rotating. After one completion rotation of gear blank, the gear blank is fed horizontally towards the gear cutter or the hob. So this process is repeated till the required depth is obtained. So this is the animation of this gear cutting process. Let's see the gear hobbing process in actual. So, so this guy is this is nothing but the gear hobbing machine. So this is the hob having the multiple cutters. It is engaged with this gear blank. So we will see the generation of the cutting of the gears on this gear blank. So supply of the lubricant is continuous to reduce the heat generation during the cutting and the wear of the teeth of the gear blank and the cutter also. So speed of this rotating cutter and speed of this gear blank so adjusted that cutting will be uniform, the depth of cutting will be uniform and accuracy will be maintained. So depth of cut is adjusted by moving this gear blank either this in forward or backward movement. So after some time we will see the depth of cut that is formed on this gear blank. So this indexing or rotation of the gear blank is continuously engaged with this hob cutter having the multiple cutters. So there is yes, so there is an vertical movement of this gear blank also as will be cutting on the gear blank. So total length of the gear teeth or the gear tooth space form is done by vertical movement of this gear blank. So by using this process, this is the gear are manufactured with a number of teeth required using the hobbing process. So guys, you have understand this gear manufacturing process. Thank you.